Power Up with Isay, Water Power, the Law of Conservation of Mechanical Energy. Hello, I'm Ria.
And I'm Isay.
We are the hosts at the Godolin Physics Center. We are exploring how different forms of energy can be transformed for use in our daily lives. In this video, we are going to look at how we can use water to create gravitational potential energy and transform it into moving energy, that is kinetic energy.
With the principle of the law of conservation of mechanical energy, we can harness the transformation of potential energy into kinetic energy to create a self-sufficient aquaponics model.
But before that, let's have a quick review on the first law of thermodynamics that says energy cannot be created or destroyed, only transformed in another form. Isay, is the first law of thermodynamics and the law of conservation of mechanical energy the same?
Good question. Arf, the law of conservation of mechanical energy is a specific case of the law of conservation of energy. It applies to systems that are only subject to conservative forces such as gravity and the elastic force.
I see. That is enlightening, Isay.
But of course, I'm Isay and I'm smart. Arf, let's start. We need 3 bottles of soda, straws, popsicle sticks, and of course, glue gun and glue sticks. Minions, do your magic. Rian, using our device, please reveal the mathematical representation of the law of conservation of mechanical energy.
Mathematically, the formula for the law of conservation of mechanical energy is C equals Ke plus Pe, where C stands for some constant. Mechanical energy is conserved for a conservative force such as gravity, but not for a non-conservative force such as friction.
Right, now let's do the demo. Let's cover the straw to prevent the water from flowing. At this site, let's say we have a GPE of 100 joules. If we want to apply the law of conservation of mechanical energy to this device, we need to calculate first its total mechanical energy by adding the kinetic energy and the gravitational potential energy. Now, what do you think is the kinetic energy of water in this case?
0. There's no movement.
That's right, Rian. At the start, when the water is not flowing, GPE is at the maximum, which is 100 joules. As the water flows, GPE is converted to kinetic energy. Using the water wheel, we can use the kinetic energy to generate oxygen as the water wheel hits the surface of the artificial pond. Once the flowing water hits the surface of the artificial pond, kinetic energy is 100 joules and gravitational potential energy is now 0.
This is brilliant, Isay. Now the law of conservation of mechanical energy is as clear as crystal.
But of course, I'm Isay and I'm smart. Arf.
Again, this is Rian from Godolin Physics Center. See you again next time as we explore the amazing world of science.